Hello and welcome. So in this video we are going to build a trading strategy with Python and a bit of SQL, and in specific we are taking a look at momentum in the Indian stock market. So what is our strategy? Our universe is the Sensex, that is the largest Indian stock market index consisting of 30 components. What we are doing is we are checking the performance over every single stock over the last 12 months, skipping the most recent month. That is due to the short-term reversal effect. I've covered that in another video on my channel. After we have done that, we are forming our portfolio consisting of the top 10% performers. By the way, you can also short the worst performers. I've done that in my other momentum video. Be kindly invited to check that out. But this time we are doing a long only strategy, meaning we are not shorting anything, we are just buying the top performers. After that, we are checking different holding periods. So we are holding this portfolio for 1, 3 or 6 months, and we are just checking how it performs. So what is our approach? First, we are getting online stock price data for all 30 Sensex components. Then we are constructing a SQL database and store the online data. Then we are requesting data from this SQL database and constructing the momentum strategy. And in the end, we are backtesting the strategy over different holding periods. As a recommendation, please watch my videos on momentum strategy, short-term reversal and Python and SQL beforehand to better follow along. If you have watched the videos, just a remark, I'm simplifying the prior videos as much as possible and I'm addressing requests people had in the comments, so for example different holding periods. I'm not working with cumulative returns this time. That doesn't mean you cannot. That being said, let's get into action. Okay, so as you see, I already imported some necessary libraries. We need yfinance to get online stock price data, pandas for data handling, SQL Alchemy to create and access a SQL database, datetime to create datetime objects, and month end to jump from one month to the other. What I also did here is I'm reading out a Wikipedia table containing the Sensex ticker symbols. So let's take a look at that together. So as you see, I'm just getting a list containing the 30 ticker symbols for the Sensex. And I can use those to request online stock price data with the yfinance library. So this is working like this, just as an example. Maybe you already know that. So if I'm just taking the very first year out of this, so Asian paint, I'm getting a data frame like this, right? And I want to get a data frame for all 30 components, and I want to store that in a list. And this is what we are doing in the next step. So let's get rid of that and create an empty list, which we are just calling data. And now I'm looping through this list containing the ticker symbols, and I'm just saying for ticker in tickers Sensex. And now I want to append to this empty list here. And I want to exactly use the syntax as I did it before. So I'm using yf download, provide the ticker, which is the element in this iteration. So if you're taking for I in ticker Sensex and take the I here is fine as well. And what I also have to do here is to reset the index. I've explained that in my Python and SQL videos. That is only due to the fact because I don't want to have the date as the index in my SQL database. So I'm just transforming the date index to a column. Okay, so let's execute that. And as you see now, the data is getting downloaded and we can proceed with the next step, which is creating a SQL database where we are storing this data in. So let's do that. So we are defining an engine here. Use the SQL Alchemy library, take the create engine function, use a SQLite database, and we are just calling that india.db. So let's execute that, and with that we have created a SQL database, so you will find this file on your system. Okay, so what is the next step? Now we want to store those data frames, which we've just pulled, into the SQL database. So how does our variable data look like, where the data frames are stored? Let's take a look together. So you see that we have a list containing elements and every element is a data frame. So we have 30 data frames, so one for every single stock. Okay, so Now let's store them in a SQL database. So we are using a loop here for, and let's just take frame, and this element should account for every single data frame in this list you just saw. For frame and symbol in data and the tickers symbols, so this list. And now we are just taking frame to SQL and defining the name. We are just taking the ticker symbol contained in the ticker syntax list. So I'm just taking the symbol here, right? And I also have to provide our engine, which we have defined here, so that pandas or Python or even SQL knows, okay, I want to store this or those data frames in the India.db database. And I also have to provide the index as false here. And with that loop, we are just storing all data frames to tables, and the table names are just the ticker symbols, right? So this is what this loop is doing, nothing more than that. So let's execute that, and now we have created but 30 tables in our SQL database India.db. So you can check that out with a database browser. I've explained that in my Python and SQL videos, but I'm not doing that here. So as said, we have created a SQL database containing all Indian Sensex stocks, right? Now we want to access this data from the SQL database. And before we are proceeding, I want to quickly explain how a query is working. Like otherwise, I think the next step will be pretty tough to understand. So if I want to request data out of this database, I would use pd read SQL. And let's just take an example. Let's select all columns from Asian Paint.bo. Right? So I've used the wrong ones here. Okay, so with that, we are getting all columns from Asian Paint. Of course, you have to provide the engine as well here. Now you see we are just getting the data frame as we would get them when pulling them from Yahoo Finance, right? But this data frame is containing too much information. So we are only interested in the date column and the adjusted close column. We don't need any more for our momentum strategy. We only need the adjusted close price and the date column. So you would need to specify select date and adjusted close from this Asian Paint, right? So this is how it's working. And we have 30 tables, right? And we would need to name the columns we are pulling as they are. So in this case, that should not be adjusted close, but that should be asianpaint.bo, right? And you can do that by using adjusted close as, and then just take the ticker syntax list and take the very first one, right? So you could take an F string here, then take tickers syntax, and I just know that this is the first entry. I just want to quickly show you what I'm doing in the next step. Otherwise, I think it's pretty tough to understand. So we're taking this one here. This should work. Let's execute that. And now you see we're getting a frame like this, right? We have a Asian Paint column description here. And this is how I'm pulling the data in the next step when looping through all those tables I'm requesting from the SQL database. So this is how it's working, right? You need to understand F strings for that. But basically, what I want to tell you with that is that you can request data using string formatting just as you would use it in Python, okay? So of course, we are adding where date is larger than I said in the beginning, I think I said last 11 years, so we're just going from 2010 on. So here we are also using where date is larger than, I don't know, 1st of January 2010, right? So, okay, I think that's enough to explain that. So let's move on. So we want to request the data, and basically what we need is a data frame containing only the adjusted close price for every single of those components. And we need one single date column so that we know when the price was there, where it is. So this is what we are doing in the next step. We are first of all creating an empty data frame, which we will populate with the table you've just saw for every single of those stocks, right? So we have an empty data frame here, and now we are populating that. We're using for, let's just name that for name in tickers Sensex. And now we're doing the following. We are reassigning the f to the f.append use pd.read SQL. And now let's get in the next line, because I think this is taking a bit longer. Yeah, so we're using an f string here. Take select as said date and the adjusted close as, and now we are using name. So we are using the element in this iteration, right? And name in ticker syntax is just the ticker symbol or the company name .bo, right? That's fine for us. So we have to specify from, and then again, we are taking, so we can just copy paste this syntax here from name, because the table name is as the ticker symbol. So we can just use the element in this iteration here. And we are saying where date is larger than, and let's just start in the beginning of 2010. Okay, and also we have to provide our engine here. So taking the engine, let's quickly check if got the syntax right. Should work at first sight. So let's execute that. Looks good. Let's take a look at the data frame now. And now you see we are getting not yet exactly what we wanted, but we are getting kind of what we wanted. We have all columns here, right? So the ticker symbols, and we have prices here. So you might think, okay, why do we have NaN values here? That is because using the append function, you're just appending the request below the already existing data frame. And as you see, the Asian paint is the very first iteration, and you see we have numbers here. So the next one would be somewhere here. And this is again starting at the 1st of January or the 4th of January as an additional rows, right? So this is why we have NaN values here, and this is why you have NaN values here for Asian paint, because the last entries for Asian paint would be somewhere here hidden, right? So yeah, this is what we have to get rid of, by the way, in the next step. So we are just trying to group this data frame by the date and then just take the sum. So why the sum? Because if I'm taking this one here as an example and group by the date for all those columns, I will get just the prices, right, for this particular date, because 163 plus NaN is treated as 0, plus NaN, and so on. It's just the price on this date. So we can use that as a workaround. As an alternative, maybe you have a better idea, you can also store the columns one by one to this data frame. But I've decided for this way, so maybe you have a better idea, be kind invited to let me know. So we are grouping the data frame by date and use the sum as set. And now if we're taking a look at the data frame again, you see that we are getting exactly what we wanted to have, right? We have all prices here starting in 2010, and we have all columns here as the company names or the ticker symbols, right? So perfect. One thing what we have to do, we have to take the current date index and transform that to a datetime index. This is necessary because right now it is an object. As far as I know, let's quickly check that I'm not telling you anything wrong. Yeah, it's an object. So we want to transform that to a datetime index, to datetime, and provide the index here. And with that, we have a datetime index, right? So yeah, we have everything what we need to move on building our momentum strategy. So the next step would be to take this data frame and get the last price in a particular month, right? So I just want to have the month end prices for this data frame to build our strategy. That's enough for that. So I can take MTL for monthly prices, or let's just call that MTL prices. And we are resampling the data frame on a monthly base, and we are just taking the last price. And with that, we are getting a data frame containing only the month end prices, right? And this is perfect for moving further because now we can build a momentum strategy. Let's say, and I'm just showing you how it works without using functions. We will build a function after that. So yeah, be a bit patient now or skip this part, but I'm just telling you how a momentum strategy for a particular formation date would work. So first, I have to define the formation date. Formation, right? And I'm just using the datetime library here and create a datetime object. And I'm just taking the, I don't know, the end of February 2011, right? So this date is the date where I'm forming my portfolio, right? So the begin of my measurement of the performance would be, so we are taking that as begin measurement, would be formation minus 12 month, right? Because we want to get 1 year back, as explained in the beginning. And I can just use the month end and provide 12 for going back 12 months, right? And the end of my measurement would be formation minus, and as I've explained, we want to cancel out the short-term reversal effect. So we are just subtracting 1 month here, right? And we have the end of our measurement period. So next, we just want to check, okay, where is the price at the end of my measurement period? And where is my price in the very beginning of my measurement period, right? And with that, we can calculate the return over the last 12 months, skipping the most recent month. So let's just use price end. And now I'm just screening my MTL prices data frame for the end of the measurement, right? I'm just checking, okay, what is the price in this date? So that should be, yeah, the end of January, right? So let's print that out. And now you see, these are the prices in the end of the measurement period, right? Okay, now we have to define, okay, but what was the price 12 months before? So 12 months before the formation date, of course. Therefore, same logic, we are just taking price, let's just call that 12 months before. And again, we're using monthly prices and log for the begin of the measurement. Yeah, this is bad. Okay. And now I have the prices 12 months ago. And with those two variables, I can calculate my return over the last 12 months, skipping the most recent month. So I can take red 12, which is not 100% correct as we are canceling out the prior month. So maybe you are calling that 12.2 or 12.1, whatever you want. I'm just calling that red 12 here. And that is just as simple as calculating a simple return. I'm taking the price at the end and I'm dividing that by the price 12 months before and subtract a 1 after that. And with that, I'm getting the returns over the last 12 months, skipping the most recent month. Pretty easy, right? And what I did in my momentum video is I'm just using cumulative returns. You can also do that, but this is an even more simpler to understand way, right? But you will get the exact same result if you're using cumulative returns. Okay, nice. So what are our winners? Our winners are, as explained in the beginning, just the top 10 performers of this red 12 series. So I can just use my winners. My winners are the red 12 and largest 3, right? So I'm getting my winners, which are Titan, yfinance, and TCS, right? So these are my winners. But the next question is, how are my winners performing when forming the portfolio and holding that portfolio 1 month? And this is what we are doing in the next step, winner return. And now again, I can use my monthly prices. And I'm screening for the formation date. So this is the price at the formation date. But I want to have it 1 month in the future because I'm holding this portfolio 1 month in the future, right? So I'm just adding 1 month here to my formation period, right? And this is my row location, okay? So this is the date I'm looking for. But now I have to somehow tell Python or pandas, okay, I only want to have the prices for my winners. And I can just use winners.index for that. So, and this syntax is just telling Python or pandas whatsoever, okay, give me the price 1 month after the formation period, but only for the winners, okay? So I can quickly show you winners index would give you Titan, yfinance, and TCS. Okay, so, but this is not the return yet, right? Because we want to divide that by the prices which they were at the formation date, right? So we are dividing by basically the exact same syntax, but without the plus month end, because this was the price at the formation period, right? And in the end, we have to subtract a 1 to get a return here. So we can execute that. And we are getting the winner return, right? So these are the returns of this portfolio components over 1 month after the portfolio formation. So Titan made 14%, yfinance 14%, and TCS 6%, right? So our momentum profit would just be the mean out of these returns, assuming we are using equal weights. So you can even, so my videos are not like build this trading strategy and this trading strategy is ready. It is ready to use, right? You have to make your own amendments. You can use weighted returns here. You can say, okay, I want to weight the first place of the winners by 60% and the rest by 40% or whatsoever, but I'm just using equal weights here. So I'm defining the momentum profit as the winner red and then the mean of those returns. So I'm equal weighting the components here and I'm just taking the average. Okay, and our momentum profit would be a very nice 11.69%, right? And again, just to make this clear, this is the profit if you are buying the top 3 performers on the formation date end of February 2011, and you are just taking a portfolio containing the top performers over the last year, skipping the most recent month. So this is what this number is about. Okay, so yeah, this is it for the strategy. And now we are wrapping that all in a function. So why should one do that? Because a function can take parameters, and we want to be a bit more flexible here, and also a function enables us to loop over this function and getting a lot of momentum profits. So there are a lot more advantages of functions, but we are wrapping all that in a function. So we are defining a function here, momentum profit. And this function is taking the formation date of the portfolio as an argument. And it is also taking a holding period as an argument. And this argument should be by default 1 month, right? And now we are just copy pasting syntax. So we are just copy pasting everything what we did here, right? So we're taking begin measurement, end measurement, and we're just everything what I just explained, we are pulling in this function, right? So I'm just copy pasting this whole block here, what I just showed you. Okay, so we have to make one amendment here. That is, when going plus month and 1, we want to change that to the defined holding period, right? So that enables us to take different holding periods into consideration. And of course, we have to return the momentum profit out of this function. So let's execute that. And yeah, how is this function working? We are providing a formation date, and this should provide us the momentum profit. So if I would provide the formation date as we just tested before, I should get the same momentum profit here. So let's test that just to be sure. So we were using the formation date of end of February 2011. So if I'm providing that here, and I have a holding period of 1 month, I'm getting the same, right? So 11.69. Yes, this is working. Okay, and with this function, we can backtest our strategy, because we just have to provide a lot of formation dates and check how our strategy is performing. And what makes the most sense is just taking the monthly prices index, which is containing all the dates in our monthly prices data frame, right? And we can just provide all those dates to this function, and here we are, we have backtested our strategy. So how can we do that? We have to care about some things here. So first of all, we are creating 3 empty lists. One is containing the profits, one is containing the dates, but the dates where we are selling our portfolio and take the profit, and one for the holding period. So we're just creating 3 empty lists here. And now we are populating them. And I'm doing that with a nested loop. The outer loop is looping through the holding periods. And I'm just taking a tuple here and take for I in 1, 3, 6. So 1 month holding, 3 months holding, 6 months holding, okay? And the inner loop is taking for J in, and now as said, I'm taking the monthly prices index where I want to loop through, but I have to start at position number 12. And that is because if I'm not doing that, this wouldn't work, as we are always going 12 months back, right? So we have to start here. And we only are able to go until minus I, because I is the holding period. So in very simple words, imagine you are in the row before the very last row, and you are holding the period for, the portfolio for 3 months. Then you wouldn't have any data, right? And this is what why I'm restricting this loop until the holding period. Otherwise, it wouldn't work. Okay, so now I'm just populating my profits. And for that, I'm using our momentum profit function. So I'm just calling that and provide the J, which is containing the formation date. So this is every of those dates. And I also want to provide my holding period, which is an optional argument. Here, this one. And this is taking my I, which is accounting for the holding period, right? Okay, so sorry. Okay, so now I'm appending the dates, and the date I'm interested in is where I'm taking the profit. And on J, I'm buying the portfolio, right? So I'm not taking any profit here. I'm taking the profit when considering my holding period. So I'm just going month end I, right? Okay, so again, this is just the date where I'm taking the profit. So what I'm also doing is I'm appending the holdings to a list so that I'm having a better overview. And I need that for forming the next data frame. So you will understand in the next step what this is about. Okay, let's execute that. Append takes no keyword arguments. So good morning. So I'm not cutting that out. Okay, so it's early in the morning. Sorry for that. I just said wrong parentheses here. So this is the right one. Okay, so now I want to create a data frame out of those three populated lists containing the profits, the date of the profit, and the holding period. So I'm just using PD data frame, and now I'm defining my columns. So I can take the momentum profit as profits. I'm taking the holding period as the holding, and I'm taking my index as the dates where I'm making this profit. So this is why I'm going I into the future here. Okay, so this should be right, hopefully. No, it isn't. So it's not my day today. Yes, because I again forgot this one or set it at the wrong place, even worse. So now I'm getting my data frame, as you see, containing the momentum profits when I make them and the holding period. And now to compare, so I think that would be pretty interesting, compare the different holding periods over the whole time horizon. I could just group this data frame by taking group by, specify the holding period, and just take the mean out of that. And with that, I'm getting the momentum profit over the last, 11 years, roughly. And you see, holding those portfolios for 1 month would result in 2%, 3 months in 6%, and 6 months in kind of unbelievable 14% on average. So yeah, India seems to be a momentum market. And yeah, so what you could also do here is to compare the strategy with the Sensex performance. So yeah, but I want to finish this video here. This is already taking way too long. So if you are interested in any additional topics, be kind invited to let me know. I hope this video was interesting for you, or at least somehow entertaining. And yeah, I'm looking forward for your comments, and please subscribe to the channel if you want to have some more content like this. Thank you very much in advance, and I'm looking forward to seeing the upcoming videos. See you next time. Bye bye.